Bismillahirrahmanirrahim. Welcome to Discrete Mathematics class. It's a lecture number 2. So today we will study about the foundations, logic and proof, which is chapter number 1 in a Discrete Mathematics books. So now the first topic is what is propositional logic. So in this chapter or in this lecture we will study about the logics, like you can already studied in digital logic designing or in programming about the logic. So the same logic is also using here. So first is propositional logic. So what is proposition now? So a proposition is like a declarative sentence. Declarative sentence mean like وقتی که شما یک چیز حقیقتش بیان میکن، آیا اون چیز راست است یا غلط، true است یا false. This is called proposition. So only proposition is the sentence which may be true, which may be false. So like you can see in example number 1 is all the following declarative sentences are propositional. میگه تمام جملات که پایین است کلش propositional است. حالا میبینیم کدومش صحیح است کدومش غلط است. Washington DC is the capital of the United States of America. حالا صحیح است یا غلط. Toronto is the capital of Canada. صحیح است یا غلط. 1 plus 1 is equal to 2. صحیح است یا غلط. 2 plus 2 is equal to 3. So آیا کدومش صحیح است کدومش غلط. کلش declarative است. حالا فقط میبینیم که صحیح است کدومش است یا غلط کدومش است. So 1 and 3 it's a true, whereas 2 and 4 are the false. So it's a declarative sentences which may be true, which may be false. That's called proposition. So you can see the second example. Some sentences that are not be proposition are given in the example. You can see sometime example like a questionary, question mark, not noun. You cannot be decided it's true or it's false. So we can be see some sentences like that as well, which is not to be propositions. So like you can see in example number 2, what time is it? So it's not a declarative now, it's a question somebody is asking. So you cannot be say it's right or wrong. Read this carefully. Again the same one, x plus 1 is equal to 2. Again x is unknown, so you cannot say maybe x is equal to 0, maybe x is equal to 1, maybe x is equal to 2. You cannot be decide here because nobody's told you that x is equal to what. Again x plus y is equal to z. So these kind of sentences are not propositions. So we use a letter like p, q, r, s, t, u, v, w, like that. It's a propositional variable and we can represent by this kind of letters. And as you know, in a digital logic design or in a computer network or in somewhere else, you study about the truth table. In the truth table, the true is denoted by capital T and the false is represented by capital F. So the same concept will be using here in a propositional logic. So coming to the first definition of propositional logics. So what kind of logic we have now? Now we are starting about the logics. So let definition number 1. Let P be the proposition. Let P, we are thinking about P be a proposition, and the negation of a P, which is denoted by this sign. What is mean by negation? Negation is opposite of something. If P is equal to 2, so negation of P will be like P is equal to minus 2. It's look like that. Like you are taking a complement in a digital logic designing. So the negation of P denoted by this letter and also can be written by this one. This is the statement. It is not the case that P. So now we are seeing what kind of a logic we are using here. Like example number 3, find the negation of proposition. So now what is the, today is Friday, so again the same thing. What is the opposite of this? sentence. So solution is, the negation is, we can be say on this way, like it is not the case that today is Friday. It is true like that as well. This negation can be more simply expressed by today is not a Friday, or it is not a Friday today. So again the same thing. What is negation? Negation is the opposite of a something. So today is Friday. What will be the negation of this? Today is not a Friday. And again the same truth table is here. P, the negation of P is this one. Negation of T is false. Negation of false is true. Okay, coming to now second definition of propositional logic. Let P and Q be propositions. Now what is the concept now here? The conjunction. What is conjunction? Conjunction mean whenever you are adding or combining two things or two sentences. Like in English grammar, you know about the conjunction, adding two sentences. Now the same is here. The conjunction of a P and Q, denoted by P with the sign of this one and Q. It is the sign of conjunction. So P, the sign of conjunction, Q is the proposition. So P and Q. Now what is the definition? The conjunction P and Q is true when both P and Q are true, otherwise it will be false. It's just like the truth table you are using AND gate. So it's look like AND gate. P and Q, when both are true, so the conjunction of P and Q will be true, otherwise it will be false. Now come to example number 5. Find the conjunction of the propositions P and Q. So where P is the proposition, so P is equal to today is Friday. So you can say P is equal to today is Friday, and Q is equal to it is raining today. So now you are going to make a conjunction. Conjunction means combine two sentences. So now how you can combine the two sentences? In the solution you can say the conjunction of these proposition P conjunction Q is the proposition, like you can say today is Friday and it is raining today. So now it's up to you how you can make a conjunction between P and Q. So you can be make like a sentences. Now it's just like a it's just like what can say, just like a logic in English now. So this proposition is true on a rainy Friday, and it's false on any day that is not a Friday. So if you say today is a Friday and it's raining today, it's okay. But if you say that today is not a Friday and it is raining today, so it will be wrong. Now it's not be conjunction, the true conjunction. So you always be make a true conjunction, the same thing. So now the second definition, because we studied about conjunction, now we are studying about disjunction. So disjunction is the opposite of conjunction. Again, let P and Q be proposition. The disjunction of a P and Q denoted by same sign, the opposite sign of a conjunction. So now you can see here in a conjunction we said P and Q, so which is the same like AND gate. Now you are seeing that P or Q, so P or Q it's same like a OR gate. So the disjunction P disjunction Q is false when both P and Q are false, otherwise it will be true. When both P and Q are false, so the disjunction will be false. Now you can see the example. Now what is the disjunction of the proposition P and Q, where P and Q are the same proposition and as in example 5? Like you can see in example 5, what was the P? Today is Friday. And what was the Q? It is raining today. So now you can make a disjunction. So disjunction of a P and Q, so P disjunction Q is the proposition. Like now you make what? Disjunction. Now the same one. So today is Friday or it is raining today. So when P and Q both are false, So when both are false, so the disjunction will be false. So now here today is Friday, or it is raining today. So now here both are true. But when both are false, the statement will be false. We can see later on in a truth table, so we will understand it better. So now you can see here table number 2, the truth table for the conjunction of a two proposition. Now it's a table of PQ and P conjunction Q. When both are true, P and Q, because I told you before in conjunction we are using AND, which is like operation of AND gate. When P and Q are true, so the result will be true. So if you remember, in an AND case we make operation like a multiplication, not the same like but like a multiplication. So T and T will be true, so T and F will be false, F and T will be false, F and F will be false. So how it can say, like you can say T is equal to 1, T is equal to 1, so 1 multiply 1, 1. So now T is equal to 1, F is equal to 0, so 1 multiply with 0, 0. So mean again F, the same, F is equal to 0, T is equal to 1, 0 multiply 1, so 0 again F, F0, F0, 0, 0 with 0. So the conjunction operation is look like a multiplication. If you assign a bit for a T and F, and we have a bit 0 and 1, so T is 0, F is 1, or F is 0, T is 1. So you can easily find the logic of conjunction. So now coming to the table number 3, the truth table for the disjunction of a two proposition, like again PQ and P disjunction Q. So if you remember again, in disjunction we are using P or Q, P or Q, and the operation or look like a OR gate. And again, if you remember that the OR operations look like a addition, not the same but look like addition. How you can say, now T's and T, so both are true, the result will be true, like T plus T, again T, then T plus F, what will be the result? T. How it make, I will tell you now. Again F and T, this one. Now come to the here, if T is equal to 1 and F is equal to 0, so what will be the T plus F? So you can easily set 1 plus 0, the result will be 1. So 1 is equal to T, so T plus F, which is equal to T. And the same for the conjunction. Now if you say T is equal to 1, F is equal to 0, so I told you before the operation look like a multiplication, so T multiply F, so 1 multiply with 0, so result is 0, and so 0 represented by F and the result is F. So now you can see the truth table of conjunction and disjunction, so you will better understand when you are assigning a bit. So now coming to the another one, definition number 4. So now you are making exclusive OR operation, and you already studied in digital logic designing and in other subject as well. So let P and Q be proposition, the exclusive OR of a P and Q. So note which is denoted by this one. is the proposition that is true when exactly one of the P and Q is true and is false otherwise. If you remember the exclusive OR operation, when one of them is 1, the result will be 1. So now see this example of a definition 5. Let P and Q be proposition, the conditional statement. Now remember the conditional statement. What will be the conditional statement? P conditional Q is the proposition FQ then FP then Q. So now we can see what is the conditional law. The conditional statement P conditional Q is false. P conditional Q is false when P is true and Q is false. Keep in mind, P is true and Q is false. So when P conditional Q is false, so the thing P is true, Q is false. Otherwise P conditional Q will be true if P is false and Q is true. So P conditional Q will be true. Now we can see an example. So it is a condition state P Q. P is called the hypothesis and Q is called the conclusion. So now see in this slide we have an exclusive OR operation and P conditional Q. So if you remember again, P and Q, so P is true, Q is true. So I told you at least just one of it will be true or just one of it will be 1. So but here both of them is true, so the result will be 4. So the P exclusive OR operation, exclusive OR with Q operation is just same like operation of exclusive OR in you studied in digital logic designing. So true, P is true, Q is false. So 1 is true, so it means true. Again F and T, so T, F and F both are false. Now again the result will be false. So again the table 3, the true table for the conditional law. So keep in mind, when P is true, Q is false. P is true, Q is false. So P conditional Q will be false. But now here both are true, so the result will be true. So P is true, Q is false. So the thing which studied before, so result will be false. So P is false, Q is true, the result will be true. And false, P is false, Q false, true. This single condition, when P is true, Q is false, the result will be false. So if you can see the example of exclusive OR, like we have a P and Q, like P and Q, and so if you can see 0 and 0, 1 0 and 0 1 and 1 1. So the exclusive OR, just one will be the higher, or one will be the true, or one will be the P will be the 1 or Q will be the 1. So 0 0, the result is 0. So 1 with 0, again P is 1, so this it will be 1 0 1, it will be 1. Now both are 1, so it will be 0. But when your T is equal to 0 and F is equal to 0, the result is 0. When T is equal to 1, F is equal to 0, the result is 1. When T is equal to 0, F is equal to 1, the result is 1, but when t is equal to 1 and f is equal to 1, the result is 0. So this is the operation of a exclusive OR. In the conditional statement, you can see just when p is true and q is false. So just think about t is equal to 1 and f is equal to 0, but the arrangement of a p conditional q will be in this arrangement, so the result will be false. So the example number 7, the example of 7 is related to the conditional. Now let p be the statement, like what should it be? Maria learned discrete mathematics, and q statement will be Maria will find a good job. So we have a two statement, p and q. So now we are going to express p conditional q statement now. So it's a conditional. Now you can say he will find a good job, f he studied master, he find a job in an administration department, f he studied administration or BBA. So conditional is f when this kind of a word is used for the conditional. So now solution is, for the definition of a conditional statement, we see that when p is the statement, like what was the statement of p? Maria learned discrete mathematics. And what is the statement of a q? Maria will find a good job. So p conditional q statement, now we can make it like in a two sense. If Maria learned discrete mathematics, f is a condition. If Maria learns discrete mathematics, then she will find a good job. Like it's true now, conditional. But we can also, Maria will find a good job. Now when, it's a condition, when she learns discrete mathematics. So it's a logic now. So it's a logic in a way, in the sense of sentences, and we will see in a truth table as well. So this is another example. What is the value of the variable x after the statement f2 plus 2 is equal to 4? 2 plus 2 is equal to is 2 now. Then x stand for assignment, so x plus 1. So we will find this no. So the in the question f x is equal to 0, before this statement is encountered, so the statement x plus 1 means that assignment of the x plus 1 to x. So what should 2 plus 2 is 4? It's true. So the assignment now x plus 1 is executed, hence because we have x value, so x plus 1, so x is equal to 0, so 0 plus 1. Now 0 plus 1 is equal to 1. So after this statement is encountered, like the if we put the value of x and the x is going to be changed, so it's just like encounter now. So we have some another concept of propositional logic, like converse, contrapositive and inverse. So we know about converse, inverse, contrapositive, but just for the statement now, so we can see we can form some new conditional statement starting with the conditional statement, like a p conditional q. It's just simple now. So we make converse, contrapositive, inverse of that. So in a particular, there are three related conditional statement did occur. So often they have special name, like now the proposition, we had a p conditional q, now we have q conditional p. So q conditional p is the converse of p conditional q. So it's a converse example. The contrapositive of p conditional q will be like q. this sign I told it's a negation, or it's a complement, or it's the opposite of the Q. So the contrapositive of P conditional Q will be negation of a Q, conditional negation of P, which is now it's totally opposite of P conditional Q, because Q is first, P is second, P is going to be opposite of P now, and Q is going to be opposite of Q. So the proposition negation of P condition negation of Q is called the inverse. This one is the inverse of P conditional Q, and this one is the contrapositive of P conditional Q. So we will see that if these three condition statement form from P conditional Q, only the contrapositive always has the same truth value is P and Q. Contrapositive, you say you are making a condition, you are taking the opposite of that, and you are making the condition. We will see in the truth table now. So now example number 9, what are the contrapositive, the converse and the inverse of the conditional statement? So now the same three conditional now. The home team wins whenever it is raining. Home team wins, like again it's two sentences. The home team wins, so it's like a sentence of a P, statement of a P. Whenever it is raining, sentence of a Q. So because Q is whenever P is the one of the way to express the conditional statement, P conditional Q, the original statement can be written as if it is raining, then the home team wins. Again it's the condition. If it is raining, then the home team wins. So again it's an example of a conditional. We have one another conditional kind of a, what is biconditional now? So biconditional means P over Q and Q over P. It's just like a operation from both sides. So we now introduce another way to combine proposition that express that two propositions have the same truth value. So now coming to definition 6 for the propositional logic. Let P and P be the proposition. By the conditional statement P conditional Q, Q conditional P, just like is the proposition P F and only F Q. Like we can see what will be the result of this by condition. By conditions when P by condition is true. Now so P by conditional Q is true. When it will be true? Now see, when P and Q have the same truth value. When P and Q have the same truth value, so P by conditional Q will be true. So we can see the truth table. P, Q and P condition by conditional Q. So true, true. Now both are true. It means like you can see T is equal to 1. So both are T, 1, 1. So T is true, Q is true. So the result is true. And if you can see the other, T is false. So P is true, Q is false. So again the result is false. P is false, Q is true. The result is false, because now it's just like a 50-50. So but we had a condition now. When P by conditional Q will be true when both have the same truth value. Both have the same truth value. If you now you can see the last one. P is false and Q is false. The P by conditional Q is true because both have the same value. So it's a truth table for the biconditional. So we have a compound proposition. Compound proposition mean you have a conditional, biconditional, conjunction, disjunction proposition. So when you are going to combine 2, 3, 4 of them, so it make a compound proposition. So now coming to this one, P Q, it's a main value P and Q. P is true, Q is true. Okay, so now here is q. Q is the negation. So what will be the negation of true? Q is equal to t, so the negation of a t is f. I told you it's opposite. True, false, false, true. So here you can see negation of f is true, negation of true is false, negation of false is true. So now we can see P disjunction with negation Q. So disjunction, you know about the operation of disjunction. P or Q, operation of or. So P with the or of negation. So true plus false will be true. True plus true is true. False plus false will be false. False plus true is true. It's operation like a addition. I told you before, the operation of disjunction is like a addition, or the operation of disjunction like a OR gate. So now we can see P conjunction Q. So now P conjunction Q, if you remember, it means P and Q. So P and Q or P conjunction Q mean its operation like a multiplication, or its operation like a AND gate. I'm saying like, not the same, but like the date way. So P and Q, true, true. So multiplication process, true, true, true. True, false, false. False, true, false. False, false, false. But if you are going to assign a value like a TT, it's like a 1 1 1 0 0 1 and 0 0. So make it addition, make it multiplication, so you will have this value. F, you can see T 1 0 1 0. So 0, it's a 1. T is mean 1. So 1, negation of 1 is 0. 0 1 1 0 0 1. So same one. So now coming to this, finding this operation. So P disjunction negation Q, we already find it here. And so the condition P, it means P disjunction negation Q is a condition with the P conjunction Q. So we already have this value and we already have this value. So it's a conditional statement. So keep in mind, what was the conditional statement? When both have a same value. So TT, both have a same, the value will be true. So both are not the same value, so false. Both are the same value, it will be true. Both are not the same values, it will be false. For the conditional statement, we need to have a same value. So whenever you are having this kind of a question, I will give you an example like P disjunction negation Q conditional P conjunction Q. Find this value. So you will know about that. PQ. So you will have this table. First you will find this thing because you don't have it. But you will find. So when you find it, then find this one, then find the whole one. So it's just present of logical operator. You have this operator represents 1, this operator represents 2, this operator represents 3, and so on. So again we have another example, and you can see the example. How can this English sentence be translated into a logical expression? Like the statement, you can access the internet from a campus only if you are a computer science major or you are not a freshman. So you can see it's a combination of three sentences. You can access the internet from a campus, it's a one only. F means conditional, you are a computer science major, it's another. Then you can see or, and you know about the or using a disjunction proposition. You are not a freshman. So solution is just like we are making let A is equal to, you can access the internet from a campus. Then you can make C is equal to, you are a computer science major, and F is equal to, you can make it you are not a freshman, or you can be write like you are a freshman. In a both way you can write, but if you are right you are a freshman, so, and you are not a freshman, it's a negation of this one. So when you are using this one, so there will be no negation, but when you are using the opposite of this, which is this one, you are a freshman or you are not a freshman, so it's a negation, so you will use the word. So now I am making the logical way of this sentence. You can access the internet from a campus, so it's a F, so it's a condition. Now F sign, you are a computer science major, so it's a C, so A conditional in a bracket C, or, so it's a value of this junction. So this junction, you are not a freshman. If you are using you are not a freshman for F, so no need of negation. But if you are saying that you are a freshman, so you are a freshman is the opposite of this one, or the negation of this one, so you will use negation signs for a F. So this is the final result of this statement. And in the same way you can you will face a question in exam. Maybe you will have this value, maybe you have this sentence, and you will make this conditional way of this sentence, or maybe you can make a sentence from this condition like this way. So coming to the example number 14, again the same. Express the specification. The automated reply cannot be sent when, again conditional, the file system is full, using logical connectors. So again the same one. If this one is Q, this statement is presented by Q up to this. Again this is a conditional. The file system is full. If you are using the file system is full, so no need of negation. But if you say the file system is not full, so you will use the negation. So you can see in a solution now. One way to translate this is to let P denote, so the automated reply can be sent, and Q denote the file system is full. So then negation of a P represent, you can be right like negation of a P. It is not the case that it is not the case that the automated reply can be sent, which can also be expressed. So this one is simply the automated reply cannot be sent. So here is just like have a kind of mistake now, because this is P conditional negation of a Q. This is P, so we can use like it's like this one, P conditional Q. If you use the same sentence which is present in a question, so this will be like this one. But if you are going to make some changes, that P will be the same, and the conditional and the Q is going to be the negation of a original sentence. So we can represent this will like this way. So coming to the example again, so this is P, and the P is the automated reply can be sent. See, here is can be sent, but here was cannot be sent, so it's a negation. It's a negation of P. So negation of P, it means you can write like negation of P and conditional. So now coming to again, and Q denote the file system is full. File system is full. So if you can make the sentence like this, the automatic reply can be sent. So can be sent with opposite or negation of this sentence, and the Q denote the file system is full. What? File system is full. So mean Q is the same one. So when Q is the same one, so you can write like negation of a P conditional Q. So it's your final answer. So you will see this kind of a question in a exam. Maybe you will observe this expression and you will find a sentence. Maybe you will find a sentence, you will make this expression. So now coming to another example, or maybe definitions. Logic and bit operation. So you know about, again I mentioned you before in table that t is equal to 1 and f is equal to 0. So the same concept is using here now. Definition 7. A bit string is a sequence of a 0 or more bits. The length of this string is the number of bits in the string. So now x, y are pq. So x disjunction y, x conjunction x and y, x disjunction y, x conjunction y, x exclusive y. So 0 0 0 1 1 0 1 1 is a truth table, you know about that, and you studied already in the digital logic designing as well. So x disjunction y are the same operation of OR. So 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1. And this is the AND operation or junction operation, like multiplication 0 multiply 0, 0 multiply 1 0, 1 multiply 0, 1 multiply 1. And this is the exclusive OR. In exclusive OR, just one of your variable will be 1, not both of them. So 0 0 0, 0 1 1, 1 0 1, 1 1 0, because both are the same, these are different, so different will have the 1. So this operation is same like a previous one, but that was represented by the capital of English alphabet, and this is represented by a bit. An example 21, AND or AND exclusive operation. So you have this value and you have this value, and the first one is OR operation. So 0 plus 1 1, 1 plus 0 1, 1 plus 1 1, not 2. If you remember the OR operation, 1 plus 1 1, 0 plus 1 1, 1 plus 1 1, 1 plus 0 0, 0 plus 0 0, 1 plus 0 1, 1 plus 1 1, 0 plus 1 1. Now AND operation, 0 multiply 1 0, then 1 multiply 0 0, 1 multiply 1 1, 0 multiply 1 0, and so on. And exclusive OR, when both bit are different, the result will be 1. Different, so it will be 1. Different, it will be 1. Same, it will be 0. Different, it will be 1. Same, 0. Different, 1. Same, 0. Different, 1. Same, 0. Different, 1. So it is the compound proposition explanation for a little bit, and now a compound proposition in another way. Again the same value of the conjunction, disjunction or conditional, but just you are representing the words by contradiction and contingency. So a truth table, again P and the negation of a P, P disjunction with the negation of a P, P conjunction with the negation of P. So again you know about the negation opposite of the value. So P is equal to T, so opposite of true is false, opposite of false is true. So now negation, now make a disjunction of a P with negation, true false, true false, true true. It's a disjunction which have the same operation of addition or OR operation, but not same like addition. up to some extent for your make it easy for your for yourself. So just think about it's like addition, and it's n1 again the like a multiplication. So you know about the De Morgan law. We studied it in a previous lecture in a sets. What was the De Morgan law, which is equal to this one. So you also can face this kind of example in exam as well, like negation of a p with the whole of p conjunction disjunction q, which is equal to negation of p conjunction negation of q. So remember it, this formula again the same, this one as well. It's a disjunction is a conjunction, it's opposite of each other, and it's also the opposite of each other. Remember it, when here is a disjunction, so there will be conjunction. When there is a disjunction, so there is a conjunction, there will be disjunction. So it's opposite of each other. So again it's an example of biconditional and negation and so on. So it was your second lecture. Study it. If you have any question regarding an example, so you can ask. Thank you.